Right, now we're going to do log equations, but first going to start with where we have one term on the left hand side of my equal sign and one term on the right hand side. So when I do log equations, you have to make sure that there are no numbers in front of your logs. You can change it from log form to exponential form by saying it's 3 to the power of 2 equals x. But if you're now stressed and you're writing exams and you're thinking that can't remember how to change from log form into exponential form, then just log both sides. Make sure that there is a log on both sides. Now, in this case, I don't have a log with my 2, so I'm going to give it its own log. So I've got log base 3x equals log, and now you have to have the same base as on the left-hand side. And in order to make 2 just being multiplied technically with 1, I have to have my base number and my number the same. Now my 2 has a log. My 2 becomes my power, because before I can drop my logs, I must make sure that there are no numbers in front of my logs. Now I can drop my log with its base. So x will become 3 squared. Therefore, x equals 9. Second one. Again, there's a 2. Now, the difference between this one and the sum number 1 is my log base number is my unknown in this case. Now, I can drop my logs after I've taken my 2 to the top. So, I've got log base x, 36 equals log base x, and this 2 makes that a squared. You all understand? Drop my logs. So 36 equals x squared. And I don't want x squared, I want x. How do I get rid of the square? I plus minus the square root of 36. Is that correct? So x is therefore plus minus 6. The only thing is, with logs, we cannot get the log of a negative number. And therefore, x only equals 6 and not minus 6. Right, applying my log laws and rules. Third one, when I don't have a base number, just like when we have an x. When I have an x, I've got my 3 ghosts. It's to the power of 1 ghost. There's a plus 1 in front of it. See? And it is over a plus 1, right? My 3 little ghosts. Now, if I have a log, my base number, if there's no number, is 10, not 16. Okay. Now, also, when I have a square root, there's a little 2. If there's a 3, there's no 2. It's a 3. And if there's a 5, it's a 5, not a 2. But if there's no number with a root form, it is a 2. Right. Now, so when I have log, bracket 9x plus 1, my base number is 10. So with other words, on the other side, I'm going to give my 3 a log of 10. Then my front numbers become my powers, so log of 9x plus 1 equals log of 10 cubed. Now I can drop my logs. So 9x plus 1 equals 1000. Michael. So 9x therefore equals 1000 minus 1. The plus 1 goes over, it changes its sign, and I subtract it now. So 9x equals 999. Oh, this is lovely. I now have to get rid of my 9 because I don't want to know what 9x is. I want to know what x is. Now x equals 111. It's a Nelson, for those who know cricket. Right, the last one, that square. It gives me a little bit of a tricky one, because that square is not only talking to my x, it's also talking to my log. So I have to first get rid of the square before I can start with my sum. So, how do I get rid of a square, Anna?
You get the square root of the whole equation.
So it's plus minus 2.
Mm-hmm.
Now, I cannot find the log of a negative number, but my log can equal a negative number. So here, I'm going to have two sums. I'm first going to have log base 3 x equals 2. And I give it its own log. What base am I going to use, Michael?
3.
3. Correct. So that becomes log base 3 x. My front number becomes my what, Billing? Power. Now I drop my logs. So x equals 9. And then I'm going to say log base 3 x equals minus 2. I give it its own log. So I'm going to have log base 3 x, and Billing, what am I going to do with a minus 2? My front number becomes my
Base.
power.
Power.
I dropped my logs. So therefore, x in this case is going to be equal to 1 over 9. Because it's a negative power, it goes under the line. So it's 1 over 3 squared, which will give me 1 over 9.